I'm almost 100. No, not years, but episodes. I'm fast approaching that 100th episode, and I want it to be special, and I want you to be involved. So I'm inviting you to ask me anything, and I'll answer in that episode. Now, that episode is going to be coming up pretty soon, so you need to get your questions into me pretty quick. Have a think what your question is, and then would you like to speak to me, or would you like to write it to me? Okay, got a question in mind? Here's how you submit it. You can record me a voice note and send it to me at my email. That's matthew@chemistrymadesimple.net. Or you can record a short message on my website if you prefer, and that's at chemistrymadesimple.net/voice note. I'll be putting that link in the show notes. If you'd rather write the question to me, again, you can use that email address, matthew@chemistrymadesimple.net, or you can send it as a DM to my Instagram @chemistrymadesimple. Okay, so what are you waiting for? Think of the question, pause, write or record it, and send it to me now. Okay, on with the episode. Hello, welcome back to the podcast. Today's episode is about the ideal gas equation, what it is, what units you need, and how to use it. Hello, and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Welcome back to the podcast. In today's episode, we're going to be talking about what is the ideal gas equation. We're going to be talking about what the terms are within that equation, what they mean. We're going to be talking about the units for each of the terms. We're going to be talking about how to use it and the common mistakes. The ideal gas equation is an equation that applies to all gases. It applies whether the gas is an element, like oxygen or chlorine, or it's a compound like carbon dioxide. It's an equation that links up the pressure, the volume, the temperature, and the number of moles. Let's define the actual equation. The equation is PV equals nRT. P is pressure, V is volume. N is the number of moles of the gas, T is the temperature, and R is the molar gas constant. In that form, the equation says that the pressure times the volume is equal to the number of moles times the temperature times the molar gas constant. Of course, for that to be true, we need to be using the right units. So let's talk about what those units are. The P is pressure, and the pressure is in pascals. We don't use kilopascals, we don't use atmosphere, we don't use bar, it's pascals. The next term is V for volume, and the volume in this case is in meters cubed, not decimeters cubed or litres, and not some other unit. T, the temperature, is in Kelvin. R, the molar gas constant, is in joules per Kelvin per mole. And N is the number of moles, it's just a number, it doesn't have units. The most common mistakes I've seen is not using the right units. In general, the units of pressure or volume are the ones that tend to trip you up. We don't usually use pressure in pascals, we tend to use kilopascals. We sometimes use atmosphere or bar. So it's really important to make sure that you're converting to pascals. Similarly with volume, the volume is in meters cubed. We don't tend to use meters cubed in most of our chemistry calculations. We don't tend to talk about measurements of meters cubed. We usually talk about decimeters cubed or litres. So make sure that if you have the volume in litres or decimeters cubed, that you're converting into meters cubed when you use this equation. Temperature is more straightforward. It's in Kelvin, and you're probably used to always converting into Kelvin when you're doing any calculation in chemistry anyway. But again, you may well be given the temperature in Celsius, and you do need to convert to Kelvin. Make sure that you do, or else the calculation will not work for you. And the molar gas constant R is usually given to you, including the units. You don't have to do any conversions with that. It's usually given to you. I can't emphasize enough how important it is to get the units right. If you're not using the right units, you might as well not even remember the equation. So what can you use this for? We can use it for working out whichever of the missing terms we need to work out. We may be asked directly or implied to work out the number of moles if we were given the pressure, the volume and the temperature. And of course, we are always given the gas constant. In that case, you need to rearrange the equation such that the N, the number of moles, is isolated on one side. So N equals PV divided by RT. Of course, you might not be directly asked to calculate the number of moles. It might be that you need to find the number of moles in order to do another calculation. For example, to calculate the relative formula mass if you know the number of grams of the gas that's present. Also, you might need to work out the pressure or the volume or the temperature if you have the information of the other two. So you could work out pressure if you have the volume, the number of moles and the temperature. You could work out volume if you have the pressure, the number of moles and the temperature. And you could work out the temperature if you have the pressure and the volume and the number of moles given. In each of those situations, it's a case of isolating the unknown constant on one side of the equation and correctly having the other terms on the other side of the equation. The equation does come up a lot if you're studying A-level, and probably a lot of other exam courses as well. You won't necessarily be directly told it's a question about the ideal gas or to use the ideal gas equation. So I would recommend not thinking about it by name, but thinking about it, what the equation actually is in terms of PV equals nRT, realising it's a relationship between pressure, volume, number of moles and temperature, and you can use it to find the unknown in order to enable you to potentially do a further calculation that might not be the ideal gas equation itself. There's a lot of uses for the ideal gas equation, and that's probably the main one. It's to help you find information to use for yet a further calculation. Okay, so what have we talked about today? We've talked about the ideal gas equation being a relationship between pressure, volume equals number of moles times temperature times R, the gas constant. We talked about the units that you must use. Pressure in pascals only. Volume in meters cubed only. Temperature in Kelvin, as you're used to using anyway. We've talked about how you might use the equation. And the uses are varied and usually not introduced. You need to realise that you're going to be using it rather than be told that you're going to be using it in an exam question. Okay, that brings us to the end of this episode. If you've got any further questions about the ideal gas equation, how to use it, or you'd like to know more information, then please do contact me. You can contact me by my Instagram account at Chemistry Made Simple. You can email me too, matthew@chemistrymadesimple.net, or you can come and ask questions in the Patreon community, and that's at patreon.com/chemistrymadesimple. Thank you to those of you who are already supporting the podcast in its Patreon. It really does make a difference. It really does help. Thank you. Thank you for taking the time to listen to this episode. I hope it's been useful to you. And if it has, please consider supporting the podcast at our Patreon. And that's at patreon.com/chemistrymadesimple. Not only will you be supporting the podcast and seeing our updates, but there's also a community element to our Patreon, so you can connect with other students, and also you can ask questions or suggest topics for upcoming episodes too. Look forward to seeing you there, and also to speaking to you in the next episode. Until then, do look after yourself, and goodbye.